Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of lines. So as per the problem, for each pair of lines, determine the size of the acute angle to the nearest degree that is created by the intersection of the lines. So let's start with the first pair. Now these two equations are given in slope-intercept form. So we have to find the slope of these lines, and from that we have to find their direction vectors, and then we'll find the angle between the direction vectors. The angle between the lines is equal to the angle between their direction vectors. General equation of slope-intercept form is y equals mx plus b. The slope of the line is the m value or the coefficient of the x term. The slope of the first line is 0.5. 0.5 can be written in fraction form as 1 over 2. The formula for slope is rise over run. Rise is in the y direction and run is in the x direction. So the direction vector of the first line is 2, 1. So for the x component, we use the run value, and for the y component of the direction vector, we use the rise value. So this is the direction vector of the first line. Now we can analyze the second line. The slope of the second line is negative 0.75. 0.75 can be written in fraction form as 3 over 4. The formula for slope is rise over run. Rise is in the y direction, run is in the x direction. So the direction vector of this line is 4, negative 3. So for x component, we use the run value, and for the y component, we use the rise value, and I assigned the negative sign to the rise value. We could have also assigned the negative sign to the 4 and not 3. The answer will be the same. But for this problem, I assigned the negative sign to the y component 3. Now we have to find the angle between these direction vectors, and that will be the angle between the lines. So for that, we'll use the dot product equation. Now we can use the vectors. For the magnitude of the vectors, we should square the components, add them, and apply square root to the sum. Now we can do the dot product on the left side. So we should multiply the x and y components. So 2 square is 4, 1 square is 1, and 4 plus 1 is 5. 4 square is 16, negative 3 square is 9, and 16 plus 9 is 25. Now we can divide both sides by 5 square root 5. On the left side, the 5's will get cancelled out. Now we can do the inverse of cos. So I get 63 degrees. We have to round the answer to the nearest degree. So this is the angle between the direction vectors and the angle between the lines. So this should be the final answer for the first pair of lines because this is an acute angle. Now we can analyze the second pair of lines. The second pair of lines are given in different forms. The first equation is given in vector form, and from the vector form we can find the direction vector of the line, which is with the parameter t. So the direction vector of the first line is 2, 4. The second equation is not in vector form. So we can rewrite the given second equation in Cartesian form by moving the 8 to the left side of the equation. We can subtract 8 from both sides. So this is the equation of the line in Cartesian form, and from this form we can find the normal vector for the line, and that's the coefficients of x and y terms. Next, we can use this normal vector to find the direction vector of the line, and for that we should flip the x and y components of the normal vector and change the sign on one of the components. So the direction vector of the second line is 4, 2. So I change the sign on the y component of the normal vector. Now we can find the angle between the two direction vectors, and for that we can use the dot product equation. Now we can use the vectors. For the magnitude, we should square the components, add them, and apply square root to the sum. Now we can do the dot product on the left side. So we should multiply the x components and y components. 2 square is 4, 4 square is 16, and 4 plus 16 is 20. And we get the same result for the second square root term. Now we can simplify the expression on the left side. Square root of 20 times square root of 20 is equal to just 20. Now we can divide both sides by 20. Now we can do the inverse of cos. So I get almost 37 degrees because we have to round our answer to the nearest degree. So this is the acute angle between the direction vectors and the lines. So this should be the final answer for the second pair of lines. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.